Hi, good morning. I am Dr.D.Sathya, working as Assistant Professor, Department of Chemistry, SNS College of Engineering. Today, in section, we are going to discuss about potentiometry. So, what is meant by potentiometry? Potentiometric is the technique that is used in analytical chemistry, usually to find the concentration of the solute in a solution. So, in this technique, the potential between the two electrodes is measured using the high impedance of voltmeter. Use of the high impedance voltmeter ensure that the current flow is negligible. So the potentiometric is a laboratory method to determine the concentration of the given analyte. So it's used for characterization of acids. In this method, there is no use of chemical indicator. Instead, the electrical potential across the substance measured. So the principle involved in the potentiometry is when the pair of electrodes is placed in the sample solution, it shows the potential difference by the addition of the titrant or by the change in the concentration of the ions. So the potentiometry, the reference electrode is the electrode which contains in own potential value and it's stable when dipped into the sample solution. Here the analyte solution is the solution whose the potential to be measured. The indicator of electrode is the electrode which is responsible for to change the potential of analyte solution. So the electromotive force of complete cell is given by the following equation. So the total cell it's equal to the reference E reference and indicator and junctions. When the E reference is the electromotive force and the reference electrode is of the reference electrode, indicator is the electromotive force of indicator electrode and junction is the electromotive force of the junction of the liquid. So the main theory involved the potentiometry is when the known potential electrode is immersed into the sample solution, then the potential is given by Nernst equation. So the Nernst equation, the E is the potential of the solution, E naught is the standard electrode potential, N is the valency of ions, C is the concentration of the sample solution. In potentiometry, the electrodes are used in to measure the voltages. So mainly two electrodes are used in potentiometry. So these are two electrodes, the reference electrode and indicator electrode. The reference electrode is mainly used for the determination of analyte by the maintaining the fixed potential. For example, the standard hydrogen electrode and the saturated calomel electrode. So the reference electrodes are classified into two main classes are as follows. Only first one is the primary standard electrode and second one secondary standard electrode. The primary standard electrode, the example is the standard hydrogen electrode. The secondary standard electrode is the silver chloride AgCl electrode, saturated calomel electrode. So what is meant by indicator electrode? It's used to measure the potential of the analyte solution comparing with that the reference electrode. Its potential is directly proportional to the ion concentration. For example, the hydrogen electrode or the glass electrode, antimony oxide electrodes, I think SbO2 electrode. There are two classes of indicator, metal indicator electrodes and ion selective electrode. So the metal indicator electrode means the develop the electric potential is responsible to redox reaction on the metal surface. The platinum or gold electrode used as metal indicator electrode. So the ion selective indicator means they are composed of ion selective membrane by which the ion crosses and it creates the imbalance. For example, the glass membrane electrode. So these electrode we are using in our chemistry laboratory. So types of potentiometric titration. So here the four types of the titrations are here. Potentiometric titrations is on category of potentiometric titration, namely acid based titration, redox titration, complexometric titration and precipitation titrations. A brief description of each types of the description we'll see. In clinical chemistry, the ion selective electrodes are present in sensors for clinical samples because of the selectivity of analytic in complex matrix. The most common analyte or electrolytes such as sodium, potassium, calcium, hydrogen and chlorine and dissolved gases. In environmental chemistry, for analysis of cyanide and ammonia, nitrate and F3 in water, and wastewater. The potentiometric titration for determining the equivalence point of acid-base titration for the possible for redox precipitation and acid-base and complexes, as well as for titration in aqueous of the non-aqueous solvents. In agriculture field, NO3 and NH4, iodine, calcium, potassium, cyanide and chlorine in solids, plant material, feed, stuffs and fertilizers. So the detergent manufacturing, the calcium, barium, fluorine for the studying effect in water quality. So in food processing, the salt content of meat, fish, dairy products, fruit juices, brewing solutions, calcium in dairy products and beer, and potassium in fruit juice and wine making, corrosive effects of NO3 in canned foods, and fluorine in drinking water and other drinks, and NO3 and NO2 in meat preservatives. So thank you.